Hello, you are welcome to the session of this physics remedial class. We are starting a new series of lectures on mechanics. And in our daily life, we come across the motion of the bodies and their impacts. Physics is the part and parcel of our life, so we have to understand the basic concepts related to mechanics. So in the first lecture, I am going to explain various quantities, various terms involved to understand the mechanics in a better way. We start with rest or motion of the bodies. I will explain you the difference between rest and motion of a body, difference between distance and displacement of the body, the difference between speed and velocity of the body, and difference between average value and instantaneous value of speed or velocity of a body. So let's take the help of this whiteboard. To understand the things in a better way, we have to divide the space into coordinate systems. And the space can be divided into three coordinates: x-axis, y-axis and z-axis. I draw it on the board. Suppose this is the two-dimensional plane and this I take x-axis and this is y-axis and this is the origin. We have to watch something from a point that is called frame of reference. So we can take this origin as the frame of reference, and from this is x-axis, y-axis and z-axis can be perpendicular to it. The entire space, the position of the body in the entire space can be watched from this point. Suppose I mark this x-axis by these points 1, 2, 3 at equal distances 4, 5, 6 in this way. In the same way, I mark this y-axis 1, 2, 3, 4, 5, 6 and so on. These are the coordinates. Similarly, on other side, this is -1, -2, -3, -4, and along y-axis of the negative side, this is -1, -2, -3, -4, -5 and so on. Now let's locate the position of a body. Suppose a body is at certain point, this A. This is the position of a body. If I check it from this origin, this body is at a distance 3, you can take it in meters, 3 meter along x-axis and 4 meter along y-axis. So this body is located at point A whose coordinates are 3 and 4. If the coordinates changes, the body changes its position, the coordinates will definitely change. Suppose this body is moving from A to point B, this one. Now its one coordinate is changing, only one coordinate, x coordinate is changing. We can say the body is moving in a straight line along x-axis. If a person is moving along this direction with the same speed, for him this body will be at rest. If the same body is moving in this direction, this is also a straight path, but here both directions are changing. You can say the body is moving along x-axis as well as on y-axis. So here the body is displaced. It is leaving its place, means there is a change in position. If with respect to time we are able to watch this change, then we can say the body is in motion, otherwise it is rest. A body at rest with respect to one frame of reference can be in motion with respect to another frame. We all on the earth are in motion if someone is watching us from the moon. So it depends upon the situation whether our frame of reference, from one frame of reference, the body is changing its position or not. So to understand the rest and motion or the motion of the body, we use the two terms, very important terms, that is distance and displacement. So first is distance, second is displacement. So what is the difference between the two? Distance and displacement. So if a body is moving from point A to point B, the distance covered is 3 to 6, that is 3. It is moving from point A to point B, the distance covered along x-axis is 3. If the same body is moving from point B to point C and its y coordinate is changing, that is from 4 to 6, it is moving by 2. So here the total distance covered is 3 plus 2, 5. But if I take this C as the final position, then its displacement is only AC, and it will be using Pythagoras 3 square plus 2 square under the root. This will be root 13. So here the magnitude of displacement is less than the distance. The distance is here 3 plus 2, that is 5. But displacement is less than 5. If the body is not changing its direction, suppose the body is going in the same direction, in this direction, same, C point is in the same line, then distance and displacement are same, magnitude is same. Displacement gives the additional information to us. It gives the additional information of direction as well. In distance there is no direction, no direction regarding information, whether the body is going in north, going in south, or in northeast or southeast, no information. But in displacement we can have the information. Suppose a body is moving between 2 points A to B, the distance is 3. Either it is moving from A to B or B to A, the distance will remain 3. Distance covered will remain 3. But if the body is moving from point A to B, we will call it, this is plus 3 displacement. This is plus 3. If body is moving from point B to A, we will call it displacement is minus 3. Means final position will be 3 and initial position will be 6 if it is coming back. So this is minus 3, final position is 3, initial position is 6, answer will be minus 3. So displacement tells us the direction of motion also. So displacement is a vector quantity, distance is a scalar quantity. But mind it, when the time interval is very small, then the magnitude of displacement and distance are same. When the time interval is very small, suppose a body is moving on a circular path. This is the trajectory or the path followed by the body, and the body is moving on this path. Then if it is moving from point A to point B to point C, at every point its direction is changing. But if I take the interval very short, then the magnitude of distance, or you can say magnitude of displacement and distance, both are same. So if the body is taking a full turn, complete turn and reaching A, then the displacement can be 0, but distance cannot be 0. Distance will be 0 only when the body is at rest. If the body is in motion, whether it is uniform motion, non-uniform motion, we will discuss all these kinds of motion, the displacement may be 0, may be negative, may be positive, but displacement cannot be 0 and can never be negative. Can never be 0. If it is in motion, can never be negative. Distance is always positive. So this is the difference between distance and displacement. So it depends upon the direction also. So if the distance is changing with respect to time, if I divide the distance with time, then it becomes speed. So the speed is simply distance covered by the body upon time taken. What time is taken by a body to cover a certain distance? The rate at which the distance is covered, that is speed. So just like speed cannot be negative, this speed cannot be negative, just like distance cannot be negative, speed also not negative. In the same way, when we divide the displacement with respect to time, displacement upon time, that will be velocity. It is velocity. So displacement can be negative, can be 0. Similarly, velocity can be negative, can be 0. If the body is moving in a circle, at every point the direction of motion is changing. At every point the direction of motion is changing. So velocity can never be constant in the circular motion because direction is changing. Now when the velocity is said to be constant, I tell you velocity has two components. What are those two components? The first component is speed part. Its first part is speed and second is direction. If either of this component is changing, either direction changes or speed changes, then we will say the velocity is changing. Velocity cannot be constant. If both are same, neither speed changing nor direction changing, that is possible only when the body is moving in a fixed direction with a fixed speed, means covering a fixed distance in fixed time interval, whether the interval may be short or long. That in that case velocity is constant. And to move a body we do not require any force if the velocity is constant. No force is required if we want to move a body with a fixed speed in a fixed direction. No force is required at all. So force is required when we have to either change the direction or change the speed or both. So force is required, and that is creating or producing the acceleration in the body. That we will come on the later stage. So based upon this information of velocity, we divide the motion in two parts. One is uniform motion and second is non-uniform motion. Motion can be uniform and non-uniform, and second is non-uniform. So a body is moving in a fixed direction with a fixed speed, it is said to be uniform motion. If a body is moving in a circular path with a fixed speed only, we cannot call it uniform motion, but we can call it uniform circular motion, because circular means direction is changing. We have already told that it is in circular motion, direction is changing, but uniform circular motion means speed is constant. It doesn't mean that velocity is constant. If speed is constant, velocity may be constant, may be variable. If speed is constant but direction is changing, velocity is variable. So in circular motion, always a force is required to keep the body on this track of circle. So that we will discuss in our next part, next lecture, about force, acceleration. Thank you all.